There are many classifications of welding methods, according to the state of the metal during the welding process. Welding methods can be divided into three types: fusion welding, pressure welding and brazing. Each category is divided into various welding methods. As for metal thermal cutting, spraying, carbon arc gouging, etc., all metal processing methods are similar to welding methods, and usually belong to the technical scope of welding. Fusion welding: during the welding process, the weldment joint is heated to a molten state, and the method of completing the welding without pressure is called fusion welding. Commonly used fusion welding methods include arc welding, gas welding, and electro-slag welding. Pressure welding: during the welding process, pressure heating or not heating must be applied to the weldment to complete the welding method. It's called pressure welding. Commonly used pressure welding methods include resistance welding, butt welding, spot welding, seam welding, friction welding, rotary arc welding, ultrasonic welding, etc. In the process of brazing, a metal material with a lower melting point than the base material is used as the brazing filler metal, and the welding parts and brazing filler metal are heated to a temperature higher than the melting point of the brazing filler metal and lower than the melting point of the base material, and the base material is wetted with the liquid brazing filler metal. The method of filling the joint gap and interdiffusing with the base material to connect the weldment is called brazing. Commonly used brazing methods include flame brazing, induction brazing, furnace brazing, salt bath brazing and vacuum brazing. 1. Electrode arc welding. Principle: the arc welding method of welding with a manual electrode. The stable burning arc established between the welding rod and the weldment is used to melt the welding rod and the weldment to obtain a firm welded joint. It belongs to gas slag joint protection. Main features: flexible operation, low assembly requirements to be welded, wide range of weldable metal materials, low welding productivity, strong dependence on weld quality depending on the welder's operating skills and on-site performance. Application: widely used in shipbuilding, boilers and pressure vessels, machinery manufacturing, building structures, chemical equipment and other manufacturing and maintenance industries. Suitable for welding of various metal materials, various thicknesses, and various structural shapes in the above-mentioned industries. 2. Submerged arc welding. Automatic welding. Principle: the arc burns under the flux layer. The heat generated by the arc burning between the welding wire and the weldment is used to melt the welding wire, flux and the base material weld work to form a weld. Belongs to slag protection. Main features: high welding productivity, good weld quality, low welding cost, good labor conditions, difficult to weld in space, high quality requirements for weldment assembly, not suitable for welding thin plates when welding current is less than 100 A, arc stability bad and short welds. Application: widely used in shipbuilding, boilers, bridges, hoisting machinery and metallurgical machinery manufacturing. Submerged arc welding can be used for all weldments whose welds can be kept in a horizontal position, on or whose inclination angle is not large. The thickness of the board must be greater than 5 mm to prevent burn through. Welding: carbon structural steel, low alloy structural steel, stainless steel, heat-resistant steel, composite steel, etc. 3. Carbon dioxide gas shielded welding. Automatic or semi-automatic welding. Principle: a molten electrode arc welding method using carbon dioxide as a shielding gas. It is gas protection. Main features: high welding productivity, low welding cost, small welding distortion, arc heating concentration, high welding quality, simple operation, high starter rate, difficult to weld with a C-power, poor wind resistance, cannot weld easily oxidized colored metal. 4. MIG welding. Melting inert gas activated gas shielded welding. MIG welding principle: an arc welding method that uses inert gas as shielding gas and welding wire as melting electrodes. The shielding gas is usually argon or helium or their mixture. MIG uses inert gas and mag adds a small amount of active gas, such as oxygen, carbon dioxide, etc., to the inert gas. 5. Principle of TIG welding. Tungsten inert gas shielded welding under the protection of inert gas. The base material and filler wire are melted by the arc heat generated between the tungsten electric ode and the weld mentor without filler wire to form a welding method. The electrode does not melt during welding. 6. The principle of plasma arc welding, the method of obtaining high energy density plasma arc welding with the help of the restraining effect of the water-cooled nozzle on the arc. Welding precautions. 1. The length of the arc. The length of the arc is related to the type of electrode coating and the thickness of the coating. However, short arcs should be adopted as much as possible, especially low hydrogen electrodes. Long arcs may cause blow pull. The short arc can prevent harmful gases such as O2 and N2 in the atmosphere from invading the weld metal, forming oxides and other undesirable impurities and affecting the quality of the weld. 2. Welding speed. The appropriate welding speed is based on the corresponding changes in conditions such as the diameter of the electrode, the type of coating, the welding current, the heat capacity of the welded object, and the beginning of the structure, and cannot be specified in the standard. Keep the proper welding speed. The molten slag can cover the molten pool well. Make the various impurities and gases in the molten pool have sufficient time to float out to avoid the formation of slag and pores in the well. When the welding speed is too fast, the shrinkage stress will increase when the welding part cools, causing cracks in the welding tube. Key points of welding wire selection. The selection of welding wire should be based on the type of steel to be welded, the quality requirements of the welded part, the welding construction conditions, plate thickness, groove shape, welding position, welding conditions, post-weld heat treatment and welding operation weighting, cost, etc. Consider, as mentioned above, the welding personnel should take anti-static measures to the tools used, especially the soldering iron used for soldering, must be connected to the ground strictly to ensure that the soldering iron does not leak. 3. All tools and equipment must be well grounded and tested for leakage. Everything is tested. You can start soldering. 4. Use high quality low temperature solder during soldering. The soldering time is less than 3 seconds and the temperature should not exceed 300 times. The pins of the circuit board and all elements should be clean and free of dust, so that they will fit better when cleaned. There are 2 ways to improve productivity. First, increase the welding deposition rate, such as 3 wire submerged arc welding. 2 process parameters are 220 at 32 V, 1400 at 40 V, and 1145 V. The groove section is small and the back is equipped with a baffle or backing. The 50-60mm steel plate can be welded through at one time, and the welding speed can reach 0.4 m/min or more, and its deposition rate is more than 100 times compared with electro arc welding. The second way is to reduce the groove section and metal deposition. The most prominent achievement is the narrow gap welding. Narrow gap welding is based on gas shielded welding, using single wire, double wire, and 3 wires for welding. Regardless of the thickness of the joint, the butt joint can be used. For example, the thickness of the steel plate is 5300 mm, and the gap can be designed to be about 13 mm, so the amount of deposited metal required is reduced several times or tens of times, thereby greatly improving productivity. The main technical key of narrow gap welding is to see how to ensure the penetration of both sides, and the automatic tracking of the arc center and the center line of the groove. For this reason, various countries in the world have developed a variety of different solutions, and thus a variety of narrow gap welding has appeared.